Okay, we're going to do some Pascal problems, problems 16 through 20 on your competency. Try and give you some helpful hints here. So problem 16, we have an atmospheric pressure above the swimming pool changes from 755 to 765 millimeters of mercury. So 10 millimeters of mercury change. We want to convert those to Pascal. The bottom of the pool is a rectangle. It's 12 by 24, so 12 times 24 is going to be our area. And we're asking how much does the force on the bottom of the pool increase? And so pressure, this is pretty easy. Pressure equals force over area. So force is going to equal pressure times the area. And of course the pressure is going to be the pressure difference. So you're going to have to figure out the difference, take it times the area, and then you'll have your force in newtons. Okay, problem 17. Dentist chair with a patient in it weighs 2,100 newtons. The output plunger of a hydraulic system begins to lift the chair when the dentist's foot applies a force of 55 newtons to the input piston, which has a radius of 5 centimeters. So you're going to do 55 over the area, and this area here is going to be pi r squared, and the radius, it says, is 5 centimeters or 0.05 meters. So you're going to do 55 over pi 0.05 squared, and that should equal the pressure in the other piston. So and you're trying to find the radius of the output plunger. So we're going to lift 2,100, and we still again have pi r squared. We don't know what r is this time, and you're trying to figure out what r is. So you can cancel out the pi's and solve for the radius. Should be pretty easy. Okay, problem 18. Person applies a force of 45 newtons to the input piston hydraulic jack, which has a radius of r1. So we're going to do 45 over pi r1 squared. And as a result, the output plunger, which has a radius of r2, applies to a force of the car. The ratio r2 to r1 is a value of 8.3. So what we're going to do is we'll just do pi 8.3 squared, and this r1 we'll just call 1. That's our ratio between those things. We want to try to figure out what this force is going to be here. So force over area equals force over area. This is Pascal's stuff. Okay, that was 18. Let's see, 19. By how many centimeters is the spring? And the spring has a K value. If you remember K values, 1,600 newtons per meter. It's compressed if the rock has a mass of 40 kilograms. So we're going to have 40 times 9.81 over the area that the rock is on, and you see in the picture it says the area is 65 square centimeters. That's okay. We don't need to put that in square meters because we're still going to have square centimeters on this side, which was 15. And you'd be able to tell me what the force is that's going to be exerted on the spring. It's asking how much is the spring compressed. If you remember, K value is force over the distance that it's stretched or compressed. So we're going to solve for D here. We're going to take the force, which we found from this problem, and we're going to divide it by the K value, which was given to us in this problem. And that would be problem 19. Problem 20. We're trying to lift a truck. We're given a pressure. We're given a radius. We know pressure equals force over area. So force is going to equal the pressure that they gave to us times the area, which is pi r squared. They gave us a radius, so I could solve that and figure out the force. What they're asking then is what is the torque that the plunger creates about the axis. And torque, if you remember, is the force times the distance to the rotational point. So the distance they give there is 3.5 meters. So once you have the force figured out from here, you could put it into there, take it times 3.5, and you'd have the torque. Hopefully that helps you on those problems, problems 16 through 20.